or ML, Artificial Intelligence or Machine Learning Based Blind State for Visually Impaired by Himanshu, Uday,
Ishan,
Nikhilesh, and Madhav. Aligned with Atmanirbhar Bharat. This project embodies the spirit of Atmanirbhar Bharat by leveraging locally available components like board speakers to create accessible technology. Our solution addresses the needs of 2.68 crore Indians who are blind, promoting social technology inclusion through scalable, affordable innovation. By developing indigenous assistive technology, we are contributing to inclusive growth and demonstrating that world class accessibility solutions can be built right here in India.
The components and materials required for innovation. For core processing, we will be using Raspberry Pi 5, Pi camera module 3, and a 10,000 mAh power bank. For sensing and navigation, we will be using HCSR04 ultrasonic, GPS module, and buzzer for alerts. For connectivity, we will be using HC05 Bluetooth module, board speakers with a mic. Structure and assembly, we will be using hollow PVC pipe which can be extended to 1.2 meters and jumper wires with breadboard and silicon cement. Tools required for this are screwdriver, drill, glue gun, and multimeter. The estimated cost of this project will be around 16,000 rupees to 17,000 rupees. System architecture. In system architecture, we have three layers: input layer, processing, and output. Input layer will contain camera, ultrasonic sensors, and GPS which will capture environmental data. For processing, Raspberry Pi 5 runs ML modules for object detection. Output, voice alerts by AirPods and haptic feedback through buzzer. Circuit connections will include power bank, HC05, HCSR04, GPS and buzzer. Ultrasonic left, GP1017, GP1018 for echo. Ultrasonic right, ultrasonic right, GPIO27 and GPIO22. For Bluetooth, we'll be using GPIO14 and GPIO15. GPS, GPIO13 and GPIO16. Buzzer, GPIO26 positive and camera CSI port.
assembly process. There are 10 steps total to it. Component procurement. We order all our products from Amazon or Avon. We prepare PVC structure. Cut the pipe into 1.2 meter and drill holes for the camera, sensor and our charge port. Add pluggability features. Add a fold hinge at 60 centimeter mark for easy carrying. Mount core components. Secure Pi 5 and power bank in handle compartments. Wire ultrasonic sensors. Connect both to HCSR04 sensors to GPIO pins via breadboard. Connect camera and Bluetooth. Attach the camera to CSI ports, Bluetooth module to transmitter and receiver pins. Add GPS and buzzer. Wire GPS module to serial pins, buzzer to GPIO26. Waterproofing. Seal all connections with silicone sealant for IP65 rating. Software setup. Flash Raspbian OS, install Python for libraries. System testing. Test scan, detect, alert functions, debug with multimeter.
The technology stack, moving on to the software stack. Raspbian iOS, which is the operating system, Python 3, which is the programming language, and ELOV3, which is the ML object detection. We got GPIO 0, which is the sensor control. We got speech recognition, which is the voice input. We got GTTS, which stands for the text to speech output. We got CV2, which is the camera processing. Serial, which is the GPS communication. We got MPG123, which is the audio playback. We got Raspberry configuration, which is UART enablement. On to the next slide.
Advantages and key features of our innovation. It's affordable. The rupees of just 9,000 cost makes it accessible to millions of people. It's also portable with only 500 grams with our foldable design. It's also waterproof with the IP65 rating for all the weather users. It has also a long battery 8 plus hours of continuous operation. The intelligence features. Real-time object detection identifies 80 objects in classes including person, peoples, vehicles, obstacles using YOLO V8 machine learning. GPS location tracking. Continuous location monitoring for navigation, assistance and emergency support. It has also voice alerts, speaks distance and object types. For example, person 2 is meters away, dash meters away, through both airports. Voice commands, hands-free operations with commands like scan ahead for on-demand detection.
This is the future development roadmap, which we can include in our project so that we can have more features. The first is enhanced ML learning. It trains custom user models on Indian-specific datasets, including photos, traffic patterns, and local obstacles. Target 95% accuracy in real-world situations. Next is advanced voice AI, that's artificial intelligence. You have to implement offline NLP, that is natural language processors. You can pocket strings for complete voice queries. You can also integrate Grok API for weather updates and contextual information. You can do sensor upgrades like adding LiDAR technology for precise 3D environment mapping, and you can extend range from 4 to 10 meters for earlier obstacle warnings. You can also integrate cloud connectivity. For that, you have to use the 5G module SIM 70600, enabling cloud-based SOS alerts, family notifications, and emergency response integration. Next, it is sustainable power. They have integrated 5 watt solar panel for self-recharging capability that can extend battery life from 8 to 24 plus hours for continuous operation. Next, companion app. You can create a companion app using Amelia Inventor. First, develop Android iOS application for family tracking, activity logs, rotate route history, and device configuration. Our mass production goal is to scale manufacturing to reduce unit cost to 500 rupees by government, making it accessible to 2.68 crore to 9 Indians. Transforming lives to innovation. This Atmanirbhar Bharat AI walking stick represents a paradigm shift in assistive technology for blind and visually impaired individuals. By combining affordable local components with cutting-edge machine learning, here-based solutions that truly embody Viksit Bharat. Our device reduces dependency on others, enhances safety through real-time obstacle detection, and provides independence to navigate confidently.
And with the potential to serve 2.68 crore users across India, this technology advances inclusive growth and demonstrates India's capability in developing world-class assistive solutions.
The path from 16,900 rupees to 50,000 per unit to skilled manufacturing will democratize access, ensuring that every visually impaired Indian can benefit from this life-changing technology.
From concept to prototype, this presentation has focused on showcasing the conceptual model and detailed design of our artificial intelligence machine learning bank state.
If this innovative model will be selected at district, state, or national level, we are ready to commence the development of fully working prototype and we will give it.
And sir, can you just cut this part?
From concept to prototype, this presentation has focused on showcasing the conceptual model and detailed design of our AI ML bank state.
If this innovative model will be selected at district, state, or national level, we are ready to commence development of a fully functioning working prototype.
And as we come to a conclusion of our presentation, we would like to thank the Buildathon for this opportunity, and we would also like to thank our school for encouraging us to pursue. Thank you.
Thank you.
Thank you.